Welcome back. Let's find out how you did with graphing y equals -3 cosine of x. To start, I would graph the basic curve y equals cosine of x. So let's do that. And this time you were asked to go from -2 pi all the way to 2 pi. And this would be -pi, this would be pi. Remember, cosine starts at 0, 1. And it has an x-intercept at pi over 2 and at 3 pi over 2. So, a little bit of a dotted line. And, of course, coming out this way, it would go down through -pi over 2, going a little too low. It would come up through -3 pi over 2, like that. So that's my cosine, just a dotted line, because it's our guide graph that we're working with. What does the -3 in front of y equals -3 cosine x do? Well, if we use the idea of amplitude that we just discussed, the amplitude would be the absolute value of -3, or in other words, 3. And what that means is this is half the distance between the maximum and minimum values. So therefore, we would say that the graph for cosine will go down to -3, and it will go up to +3. But what about the negative part of that? What that does is it reflects the graph about the x-axis. So we will include a reflection within this change in amplitude. So the graph, instead of, first of all, going to a height of 1, it goes to a height of 3, but in this case, it would actually start down at -3. And this value of -1 would be reflected over to the x-axis, but in addition, it goes up to a height of 3. This value would get reflected up to a height of +3. These two values at the end, of course, would go down to -3, and that would be reflected down to -3. So my curve is going to go through the same intercepts, the same x-intercepts, that is. And so what my curve looks like then is this graph right here. And that's the graph of y equals -3 cosine x. Now that we have seen how the amplitude affects the sine graph or cosine graph, including reflecting the graph about the x-axis, let's look at another way to vary the graph of a sinusoid. Graph both functions, y equals 2 sine x and y equals sine x, and compare them with each other. So, once again, to graph those, I would start with y equals sine x, and hopefully, at this point, you're getting more and more used to what that sine curve looks like. So, I'll start it at -pi, I'll go through pi, and we'll end at 2 pi. Remember, it goes up to a height of 1 and down to a minimum value of -1. And I'm going to lightly just dash the graph in there for us. So that's my sine curve. Well, the one we're dealing with, y equals sine of 2x. The question is, when we were doing stretching and shrinking, how did multiplying a whole number times x affect the graph? Well, what it does is it shrinks the graph by a factor of 2 in this case towards, or to say horizontally. So another way to look at it is that it's going to squish it up. So what would that look like then? Well, what it means is this point, which is at 2 pi, gets squished to half of that, or in other words, pi. Let me take this endpoint. This endpoint actually gets squished halfway, which means to negative pi over 2. Well, what does that do, for instance, to this height here? Well, that's right at pi over 2, so it gets squished by a factor of 2, so that height then becomes at pi over 4, to give you an idea. So what's going to happen here? We're going to get a graph where we see the entire sine curve happening in half the amount of space. Or another way to look at it is we're going to see the sine curve. We're going to have 2 complete cycles of the sine curve in the amount of space that we used to have 1. And so let me finish this part off just to be complete in terms of this would be my graph for sine 2x. And you can see, again, that it's either been squished this way, or you can think of it as we get 1 complete cycle in half the amount of time, or we get 2 complete cycles in the same amount. Now let's look at another example of this type of varying the period of the graph of a sine wave. Cosine y, or graph y equals cosine of 2/3 x, and y equals cosine x over the interval 0 to 4 pi. Well, this time what I'd like to do is use the calculator to graph those 2 curves. What I've done actually is plugged them into the calculator already, so I don't have to enter the equations, and I've also put the correct interval in there. But let's look at them and see how that 2/3 affects that period. So let's go to my graphing calculator. I hit my y key, and I can show you that I've already plugged in y equals cosine x, and y sub 2 equals cosine 2/3 x. When I hit the graph key, you will see it draw the cosine x curve first, and then the cosine 2/3 x. So here we go. Here it's drawing the cosine, and now it's drawing cosine of 2/3 x. Well, what's happened there? What I hope you notice is that it has been stretched out. The 2/3 in front of the x actually stretches this graph horizontally. So therefore, what we've noticed is that a fraction, which is less than 1, stretches the curve horizontally, whereas a whole number, integer, greater than 1, shrunk the graph. So let's look at a generalization for the effect on the period of the sine and cosine curves. For b as a positive number, the graph of y equals sine bx will resemble that of y equals sine x, but the new period will be 2 pi divided by b.